Hi students, so today we are going to see the chapter polynomials. So first of all, let us going to see what do you mean by polynomials. So a polynomial, it is nothing but it is an algebraic expression. So this expression, it will be of the form a0 x power n plus a1 x power n minus 1 plus a2 x power n minus 2 plus and so on up to an. For example, if I just consider 5x square plus 2x plus 7. So this is a polynomial. Okay, so and if I just consider 2x cube plus 3x square plus 5x plus 4, this is a polynomial. Okay, so we say that an algebraic expression which is of the form, which is of this type of form, which is of this form, we call that to be as polynomial. So if the polynomial of degree 1, we say that to be a linear polynomial. If the polynomial of degree 2, we say that to be as quadratic. If the degree is 3, then we say that cubic. Like that it goes on. So here in this expression, if you just consider this expression, this a0, a1, a2 and so on up to an minus 1, an, all these are nothing but the coefficients of this particular values. Okay, if I say a0 means a0 is a coefficient of x power n, a1 is a coefficient of x power n minus 1, like that. And the last term an, that is you just consider here 7. So this we call that to be as constant term. This we call that to be as constant term. So an is nothing but the constant term. For example, as I already said you, if you consider 5x square plus 2x plus 3, this 3, it is a constant term. 5 is the coefficient of x square, 2 is the coefficient of x, and 3 is nothing but the constant term. The next one is degree of a polynomial. So what do you mean by degree of a polynomial? So degree of a polynomial is nothing but the highest power in x, we call that to be as degree of a polynomial. If you just consider this equation, okay, if you just consider this quadratic equation, what is highest power? Highest power is 2. So the degree is 2. If you consider a cubic polynomial, say 4x cube plus 3x square plus 2x plus 7. So what is the highest power? Highest power is 3. Okay. The next one is constant polynomial. What do you mean by constant polynomial? Constant polynomial means the degree will be 0. As we already said, already we had discussed. So the last term we call that to be as constant, isn't it? So this is a constant polynomial. That is, if I just consider just 5 alone or 7 alone means, then the degree, this 5, I can write it as 5x power 0, isn't it? So what is the degree of a constant polynomial? It is 0. So what is the degree of a constant polynomial? It is 0. Next we are going to see the linear polynomial. So linear polynomial is nothing but we have the degree value to be as 1. For example, if I consider 5x plus 7. Okay, if I consider 5x plus 7, what is the degree of x? X value, degree of x is 1. So that we call that to be as linear polynomial. What do you mean by linear polynomial? The degree value will be 1. Next one is quadratic polynomial. Quadratic polynomial is nothing but we will have a degree to be as 2. For example, if I consider x square plus 2x plus 3. So here what is the degree? The highest degree is 2. So it is a quadratic polynomial. The next one is cubic polynomial. Cubic polynomial is nothing but we will have the degree to be as 3. For example, x cube plus 3x square plus 2x plus 1. If I consider this polynomial, the highest degree is 3. So it is a cubic polynomial. If I have the degree to be as 4, then we say the biquadratic polynomial. The next we are going to see the value of a polynomial. So what do you mean by value of a polynomial? How to find a value of a polynomial? The value of a polynomial p of x at x is equal to k, where k is a real number, is denoted by p of k and is obtained by substituting k for x in the polynomial. For example, if I consider a polynomial p of x is equal to 2x plus 1, and we have to find the value of polynomial, if the question is find the value of polynomial, at x is equal to 1 means just you have to substitute the value of x, so that we get 2 into 1, that is in the place of x we have to substitute 1 plus 1. So 2 ones are 2, 2 plus 1, this gives 3. So this is the value of the polynomial. Just you have to substitute the value of x in the given equation. So that will give you the value of polynomial. Exercise 2.1. The graphs of y is equal to p of x are given in figure below. For some polynomials p of x, find the number of zeros of p of x in each case. So here we have to find the number of zeros. Okay, the graphs are given. You have to find the number of zeros. This is very easy exercise. How you will find the number of zeros in the given graph. So the graph is given. You have to find the number of zeros. So this is obtained. Just you have to see the graph in the x-axis. If the graph touches in x-axis, the number of points the line touches the x-axis will give you the 0 of p of x, 0 of a polynomial. So here you just consider this graph. The line, it doesn't touch the x-axis itself. X-axis is here. X-axis inge irukku. Okay, in the line inge irukku. Idu touch பண்ணவே இல்ல இல்லையா? So we say that there is no zero of p of x. Okay, so what we will say? We will say that there is no zero as the graph does not intersect the x-axis at any point. So the graph, it does not intersect at any point in the x-axis. So there is no zero of p of x. Now consider the second graph. So here in the second graph, this curve, it touches the x-axis. Where is x-axis? This is x-axis. So it touches at one point. So how many number of zeros? So number of zeros. So how many zeros are there? So the number of zeros is 1. So the number of zeros is 1 as the graph intersect at one point in x-axis. Is it clear? So the graph intersects at one point in x-axis. Third graph. So here in this graph, the curve touches the x-axis at 3 points, isn't it? 1, 2, 3. So how many zeros? 3 zeros. So the number of zeros is 3 as the graph intersects x-axis at 3 points. The next fourth graph. Here the graph touches at how many points? Here the graph touches the x-axis at 2 points. So number of zeros is 2. So number of zeros equal to 2. And for the fifth one, here the graph touches at 1, 2, 3, 4. 4 points. So the number of zeros is equal to 4. So thus we completed exercise 2.1.